All right, we're going to look at section 3.3 notes. So there's a lot of information in here. What we're talking about is a couple of concepts. We're talking about finding more zeros, and sometimes you can't necessarily see the zeros, so there's some tricks to how to figure out what the zeros are. So one of the concepts we're going to talk about is a concept called multiplicity. And that's when a polynomial has a root that repeats multiple times. And a good example of that is x squared plus 6x minus 9. You know how to factor that into x plus 3 and x plus 3. And you can FOIL that out and prove to yourself that that's what we have here. It's a trinomial squared. So that can technically be written as x plus 3 raised to the second power. So that means that this is a polynomial that has a root of -3 with a multiplicity of 2. And as we learned in the last section, an even multiplicity means that it's going to touch or bounce at -3. And you can put that in your calculator and just show it to yourself. So another concept here is the number of zeros. And based on the highest power, if it's a fourth power, you're going to have 4 roots or zeros. If it's a fifth power, you're going to have 5 roots or zeros. So that's one of the things we're going to keep working on, is finding all of those roots or all of those zeros. So one of the concepts that will help us with this is something called the rational zero theorem. And this can be frustrating, but it can be helpful at times. So what the rational zero theorem tells us is what are the possible rational roots. It is possible also that none of these roots will work. It could be that the polynomial has no rational roots. It could be also that the polynomial doesn't have any real roots. So a rational number is any number that can be written as a fraction. So for example, the square root of 2 is not rational. But it is possible that you could have that as 0. It's just not going to show up in this list. So to find the rational roots, you take all of the factors of the last term. So all of the factors of p are going to be 1, 2, 3, 6, 9, and 18. So 1 times 18, 2 times 9, 3 times 6. And all the possible roots of q are going to be 1, 2, and 4. And then you find all of the fractional representations of p over q. So it could be 1 over 1, 1 over 2, 1 over 4. And then it could be 2 over 1, 2 over 2, but technically we've already done that one. 2 over 4, we've already done that one too. 3 over 1, 3 over 2, 3 over 4. 6 over 1, 6 over 2, 6 over 4, and then we keep going and we have all of these possible rational roots, positives and negatives. So it could be +1 or it could be -1. It could be +1/2 or -1/2. And then if I didn't have a calculator, I would sit there and start testing these roots. And the frustrating thing is that I could test all of these roots and none of them will work. And then I've spent all that time testing roots. But they are helpful at times. So here we have another example. So we have p and q. Q is 2. I forgot to write that. So to find all of our possible rational roots, we write all of the factors of p, 1, 2, 7, and 14. Then all the factors of q, which are 1 and 2. And then we write all of our possible roots. 1 over 1, 1 over 2, 2 over 1, 2 over 2. Notice I X'd that one out because that's the same thing as 1. 7 over 1, 7 over 2, 14 over 1, 14 over 2. And I X'd that one out because that's the same thing as 7. And all of these potentially could be plus or minus those roots. So then here on the next example, you'll see what we're doing is we're taking that information. So on this example in the back, it says find all the rational roots. Well, we did that on the previous problem. Well, now it says start doing synthetic division or start testing them. Well, I'm going to save y'all a little bit of effort here. So we're going to look at our calculators, and I've got 3 functions in here, so I have to take this one out and put this one in. Okay, so when I graph this polynomial, this is the one that we're looking at here. you'll notice that there's a 0 here that appears to be at about 1 to 3.5, negative 3.5, and another one here that appears to be between negative 1 and negative 2, and another one here between 1 and 2. Well, if we look at those possible rational roots, there's no number between 1 and 2, and there's no number here between negative 1 and negative 2. So, but there is this number 7/2 that's between negative 3 and negative 4, which is about where we're looking at. So that gives us a starting point. So we're going to start doing synthetic division with negative 7/2. And if you notice here, when we did synthetic division with 7/2, it does work out to be 0, which means it is a root. So then what I'm left with, since I started with an x cubed problem, I'm left with an x squared problem. So now I have 2x squared minus 4 equals 0. And then if I move my 4 and divide by 2 and take the square root of both sides, I end up with plus or minus square root of 2. The square root of 2 is like 1.4, so that makes sense that it would be a number between 1 and 2. So my roots are negative 7/2, square root of 2, and negative square root of 2. So I have 3 roots because I have a power of 3, and these are my factors. And I can write this factor like this, or I can write this factor like this. So here's another example. All right, so P here is 9 and Q is 2. So my factors of 9 are 1, 3, and 9. My factors of 2 are 1 and 2. So all my combinations would be 1, 1/2, 3, 3/2, 9, and 9/2. So again, if I go to my calculator, and we're going to take this one away, and we're going to put this one on. And if I look at my calculator, you'll notice that I have something over here between, I think it's negative 4.5, and we have this one here. It appears to be negative 1, and here it appears to be positive 1. So I'm going to take a chance, since positive 1 is one of my possibilities. Oh, and remember, all these are plus or minus. And I'm going to do synthetic division with 1. And after I did synthetic division, it does come out. So my depressed polynomial is now negative 2x squared minus 11x minus 9. Well, since negative 1 also appeared to be a root, I'm going to try negative 1 and see what happens. And when I do negative 1, it also works. So I ended up with negative 2x minus 9 equals 0. That's my depressed polynomial. And that's a linear, so I can just continue to solve it, and I get negative 9/2. So it's exactly what my calculator was showing me. I had a root at 1, negative 1, and negative 9/2, and my factors are x minus 1, x plus 1, and x plus, 9/2. Okay? So another process that we can do is called Descartes' rule of signs, and what this does is help us figure out how many positive and how many negative roots we possibly should have. So the way that we do that is we take the polynomial and we check sign changes. So if you notice, there's a sign change right here, so that's 1. There's no sign change here, so there's not a sign change here. There's another sign change here, so that's a second sign change. There's no sign change here. And there's a sign change here, so there's 3 sign changes. So I'm just looking that this went from positive to negative, this went from negative to negative, this went from negative to positive. That's all I'm looking for. So there are 3 sign changes. So that means that there are a possibility of 3 positive zeros. Now the thing about this is that they're always going to come in powers of 2. So there could be 3 or there could be 1. So you always take whatever you get and you subtract 2 from it if you can and figure out how many other possibilities. So that means that there could be 3 positive zeros or there could be 1 positive rational zero. Okay, so to figure out negative sign changes, I'm going to put a negative in for x, and then I'm going to reduce this. So negative x to the 5th is negative. Negative x to the fourth is positive, but there was a negative 3 already. Negative x cubed is negative. Negative times negative is positive. Negative x squared is positive. Negative 35x and minus 42. So here we go again. There's no sign change here. There's a sign change. No sign change here. There's a sign change. No sign change here. So there are two sign changes. So that means that there are two, and remember I always subtract 2 from it. So that can be 2, or there might be no negative roots. Alright, so let's try this example. So again, we don't do anything to the polynomial, we just check it. So yes, there's a sign change. Yes, there's a sign change. No, there's not. Yes, there is. So there's 3 sign changes. So there's 3 or 1 possible positive roots. Okay, here I put in the negative. So I got negative, so that's negative to the fourth power is positive. So this is all positive. This is going to be negative times negative is positive. This is positive. This is negative, and this is minus. So there's no sign change. No sign change. There's a sign change here, and there's no sign change here. So that means there's 1, and since I can't subtract 2 from that, it's just 1 possible negative root. Alright, so on this last example, we're putting everything together. So, here's my problem, and I want you to tell me about far left and far right behavior. So we're going to say the left is up and the right is up. Since 4 to the x fourth is a positive number, coefficient, and an even power, that's how I know that it's left is right. Left is up and right is up. How many turns are there going to be? The number of turns is always n minus 1. Well, this is a power of 4, so 4 minus 1 is 3, so that means there are going to be 3 turns. So that means that there are going to be 3 maxes and mins. How many zeros are there? There are going to be 4 zeros or roots. Since it's x to the fourth power, that means I have to have 4. And then it says, use Descartes' rule to figure out how many positive and negative roots there are. So I did my Descartes' rule with the original, and I said that there could be 3 or 1 positive. And then I did my Descartes' rule with the negatives, and I came out with there's only 1 negative. So if there has to be 1 negative and there are 4 total zeros, then that means there must be 3 positives in order to make this work out right. So that gives you a little bit of a hint on what kinds of numbers you're looking for. So then you can do your possible rational roots. I'm sorry, and I wrote this wrong. P is the 9, Q is the 4. So all of my possible rational roots are 1, 1/2, 1/4, 3, 3/2, 3/4, 9, 9/2, and 9/4. Okay? And then again, I'm going to go to my calculator and I'm going to go to y equals. And I'm going to go to that polynomial and I'm going to look at it. And when I look at this polynomial and I graph it, you'll notice that right here it seems to cross at -1. And right here it appears to cross at 3, I think that is. You could always verify it with the table. So at -1 it is 0. At 3 it is 0. So since I need to start synthetic division now, I would probably start with -1 and do synthetic division. And then I would do synthetic division with 3 based on the information that I have. And at that point in time, I should now have a quadratic and I can figure out what to do next. Hope this helps.